today we're back in the laboratory. Nice laboratory. Right, and we're going to build a speed controller or voltage controller for what I want it for is just to energise a fan, a 240 volt fan, 500 watt. Okay, now I could have gone out and bought one of them, 240 volt, right, for over 200 quid. I didn't want to do that, so I thought, well, I'll get one of these, I'll be able to wire that thing up so you get 240 volts out of it without blowing that thing up. Because you could just put a dim bulb on it, a light bulb in series with it. That'd work. People don't like the idea of doing that, they don't. So I thought, well, all right then, I'll do it all a nice proper way, well, a funny way. And I hope all these posh electricians, because they're a funny cult, they've got a cult unto their own, electricians are, they're not like carpenters, plumbers or gas fitters or water people. No, they think they're gods, right? So it's very difficult to siphon information out of a lot of them. Really want to hide their little pathetic secrets. It's a shame, because the world would be a better place if they didn't. So what I've got to do here, what I've decided to do, this is a step-down transformer. And it's down here. Yeah, it's just a meter in it. And I'm going to turn it around and have a look. Yeah, there's a label on the back. It says step-down voltage converter, 240 volts in, or 220, 120 volts out. So that's not no Variac. You can't get no over voltage from it at all. And it's a power of 1 kilowatt. And that works a bit strange on these things. Right, what Variac actually does, I know that. Okay, so we can have a couple of amps going through there. The output of that, I changed from that Euro socket, stupid things, to a UK plug hole. That's my kettle plug-in plug. That's alright, because there's plenty of them about in this country, you know, they're all for computers. So, I put my 240 volts in there, 120 out here, which will go into here, and to here. And that way, I've got a little bit of over voltage. But the way I'm going to do it, it's going to be quite a lot. You see, this Variac is 235 volts output from 115 volt supply. Well, we're going to give it 120 volt supply. Right, 120 volt supply, so we're going to get more than 135 volts out of it. A kind of 15 amps is available without burning the thing up. And then it'll go into the site transformer. Okay, back to front, mind, back to front. So these are 16 amp, 100, what is it? 110, 120, I don't know. It don't matter. Oh, hang on. What's that there? Just 16 amps. 240 volts in. Don't even tell you what comes out of it. Oh well, 110 volts. 110 volts if we put 240 volts into it. So, this will be interesting to find out. If I put the output of the Variac, which would be, so 135, maybe 150 volts, into there, and then take him out of the normal input, take him out of there. So I'll put a socket on the back and put a socket on the back of there. See, we can put a socket on the back of there, can't we? And and then we'll have an output It's adjustable with this thing from say 130, say 830 volts into here. Then we should easily get 260 volts out of it. I don't want that extra voltage, I'm just saying it's there if I want it. I'll measure it later, but when I've done it, because I ain't started when I've started. And I've got to take all the bits out, ain't I? Because that's all that these step-up transformers are. It's just a transformer, chassis transformer, panel mount transformer thing. 2 to 1. And the input goes on here, from here, 240 volts in, to this thermal switch protection unit, into these windings. Look at the siding windings, man. Whoa. Goes on that side and this side comes out. Look at the size of these windings. Look at the size of them buggers. Right. Now bars, a couple of bars, it ain't wire. I need a loop up to get in parallel to get these two out of here. So you've got 32 amps total. Total continuous power, safe, supposedly. Don't know how, it ain't got no ventilation in here at all. All fans to cool it. Still, it's rated at 3.3 kilowatts, plenty of power. And this way, I'll be able to control whatever load I got on it from 0 to faster or more power if you need it. And I'm going to put the UK plug on the back of there, see, and go on like that. So, for doing the job of one 240 volt, this would cost me cheaper than buying a new 240 volt auto Variac, auto transformer should I say, Variac. It's cheaper. That was 27 I think, that was 57 or something, and this was 35. Anyway, it cost me about £130 altogether. You can't buy one of them for that, 240 volt, you can't do it. So, that's what I do. And it's going to be more versatile, better. But I've got to buy 3 things, that's insane, isn't it? So I'll do another video on the update when I've de-gutted this machine. Okay? Here's something I thought I might show that people often don't show on the internet. I've never seen it demonstrated that today, which is a bit of a shame. To get these push-on fits for these contacts there, these terminals. You know, a lot of people get pliers on them and wrestle like mad with them because they stick in there, they stick in. Pull them and that. It's strange, I think, but you don't need to do that. If you've got access, you can just, there's always a hole in them, but the hole's covered up by that bit of steel there, and that's pushed in, which makes a dimple there, with a protrusion that pushes through the hole, so it locks them on so they don't fall off, right? Which makes it very difficult to pull them off, unless, well, I use a probe off the little meter, the test meter, nice pointy end, could be a screw, could be a nail, could be anything. Find a little hole, just push it, and then you get a screwdriver in, and then they just pull up. Simple. Just by pushing onto that centre bit there, and it flattens it out and you can just slide it off easily. Just a quick tip.